Moving on to chapter 4, but first we need to solve the bell problem. Okay, notice we have 4 variables this time, so go ahead and make this into a matrix. It should be a 4 by 5 matrix. Do the steps to solve the system, and when you do that, you should get us the solution of 1, 1, 1, 1. So, moving on to 4.1, like I said, it's about quadratic functions and transformations. When we are talking about quadratic functions, that means it forms a parabola. So far this year we've only talked about linear equations. We're now going to talk about quadratic equations, which form a parabola, which is in the shape of a U. It can be opened up, or it can be opened down, just like an absolute value graph. And notice how it has a curved form. So a quadratic function is in the form of ax squared plus bx plus c, where a, b, and c are all numbers. And notice how our highest power is 2. That makes it the quadratic function. Next, our vertex form is what helps us determine what our vertex is. And our vertex will be hk. It's a point. It's the lowest point on our graph, or the highest point. And our axis of symmetry, number 4, is a line that divides the parabola into 2 mirror images. So our axis of symmetry goes right through our vertex, and if we were to fold our parabola in half, it would give us the same exact image on both sides. So like I was saying before, the vertex of our parabola is hk. We have our little graph here, and it's the intersection of the parabola and its axis of symmetry. So again, if our graph is opened up, it's the lowest point, and if it's opened down, it'll be the highest point. Which then brings us to our maximum and minimum value. So the minimum maximum value is always the y value of the vertex, since that is the lowest point, or minimum. Or if we had a graph open down like this, our highest point up here is our vertex, and that will be our maximum point. Again, it's the y value because we're moving up and down. So this is a standard form for a quadratic equation. Again, notice how it forms a parabola, which is in the shape of a U. Remember, this line here is our axis of symmetry. I abbreviate that all the time with AOS, axis of symmetry. And again, don't forget the point at which your parabola and axis of symmetry intersect is your vertex, and it's represented with HK. Again, it is an ordered pair. And as always, every single function has a parent function. When we talk about quadratic equations or functions, if we're not adding or subtracting anything from our x squared term, we will always start at the point 0, 0, which makes our axis of symmetry x equals 0. Notice it is a line. It's going straight up and down, so it goes through our x-axis. And it is always the x value of your vertex. So if we were to have the number out front of our x squared term to be positive, that means our graph will open up. If you notice, this point here is the point at which our graph intersects the y-axis. Since our x value is 0, we are only left with the constant term at the end for our y-intercept. And this formula here will help us determine our vertex. And then if we have our a value less than 0, or it would be negative, our graph will open down. And still our y-intercept, since we plug in 0 here and 0 here, we're left with our constant term c. So we have a couple properties. If our graph is narrower, it's called a stretch, which means the number out front of our x squared term is greater than 1, so like 2, 3. If our graph opens up wider, that's called a compression, and our value out front of our x squared term is less than 1, which means it's a fraction. So remember, fraction ends in ION, and so does compression. So that will help you. ION, ION. Now to figure out our axis of symmetry, this is the formula we use. X equals negative b over 2a. So again, b is the number in front of your x squared term, your x term. A is the number in front of your x squared term. And again, it's x equals because it is a line. And like we already said before, a y-intercept, Since we plug in 0 for our x's, we're left with the constant term. So we already talked about stretch and compression. The last part is reflection. Obviously, if it opens down, it's going to be a reflection in the x-axis, and it will have a negative x squared term. Kind of talked about this in the vocab. Again, our minimum value is the lowest point of our graph. So if our graph opens up, we'll have a minimum, and if it opens down, we'll have a maximum, because it's the highest point of our graph. So let's get started. We have to graph the function y equals 2x squared. So we first need to pick some x values and then plug them in to find the y values. So I'm going to pick x values, couple negative, couple positive. Okay, and then we plug them in. So we plug in -1. Remember, anytime you square negative, it is positive. So -1 squared is 1. Times by 2, we get 2. Go ahead and plot that point. So at -1, 2. Plug in 0. Obviously, 0 squared is 0. 0 times 2 is 0. So we plug that in here. Plug in 1. 1 squared is 1. Times 2, we get 2. So at 1, we're at 2. Plug in 2. 2 squared is 4. Times 2, we get 8. So that's going to go off our graph a little bit. And plug in 3. 3 squared is 9. Times 2, we get 18. I'm not going to plot that point because we'll be way off our graph. So now we connect our points. It should have a little curve shape to it, which is kind of hard to do for me, but it should be in the shape of a U. Okay? So our way to find our vertex, remember, it is the lowest point of our graph. So since our lowest point of our graph is at 0, 0, our vertex is at 0, 0. And remember, the axis of symmetry is always x equals, because it's a straight up and down line. And it's always equal to the x value of your vertex. So since our x value of our vertex is 0, our axis of symmetry is x equals 0. Then we have to determine if we have a max or a min point. So if we look at our vertex is the lowest point of our graph, so it will be a minimum. And then we got to look at the y value of our vertex, which is 0. So our minimum value is 0. And the last step is our transformations. Did we stretch or did we shrink? Or did we stretch or did we compress our graph? Since the number out front of your x squared term is greater than 1, it will be a stretch. So those are the only transformations we have learned so far. And there's your first parabola that you graphed. So go ahead and plot your points, figure out some x values, figure out some y values, and go ahead and graph them, and then I'll help you with the vertex, axis symmetry, maximum, and your transformation. So I would pick even numbers since we're multiplying by -1/2. So I picked -4, -2, 0, 2, and 4. And a couple points that I got were -2, -2, 0, 0, and 2, -2. So those will be our points to graph that fit. Again, notice how it opens down this time. And look to find our maximum point, our minimum point on our graph. So our point is 0, 0. Our axis of symmetry, again, is the same as your x value of your vertex. And it's always x equals. And our x value is 0. Then we got to determine, is our vertex the highest or lowest point of our graph? It is the highest, so it will be a max. And it goes with the y value of our vertex, which is 0. And this time we have two transformations. Again, notice how we have, it's flipped down, so that's a reflection. And then notice how the number out front of our x squared term is a fraction. That means we have a compression. So our two transformations are reflection and compression. And you are done. We'll work on this in class tomorrow.